Hello everyone, Mr. Minnick is my name, math is my game, and on today's lesson in Algebra 2A, basically this is going to be an intro to factoring. And before we get into the intro to factoring, we're going to kind of pick up where we left off. The last thing we did, we were given 3 points, like 0, 5. So we'll just say that that's some point. We don't know if it's the vertex, but at some point, 0, 5. Another point might be 2, 3. Another point might be 2, 3. We'll call that the point Q, and then the point R might be negative 1, 0. Okay, and the goal is to try to write a quadratic function given those 3 points without a calculator. That's going to be tough. The key to this was using standard form, which was ax squared plus bx plus c. And that's what y equaled, but I think when we set these up, we wrote it equals y like that. I don't know if anybody remembers seeing this. I know I told you I'm not going to hold you to you know, the day we did this lesson, we did all these with a calculator. But if we take this first point here and we make some substitutions, what we're going to get is we're going to get c equals 5. And the cool thing is, our answer, we got 1/3 of our answer. Our answer is going to be y equals some a value x squared plus some b value plus 5. So in the way of our answer, if you just did that, you're going to get 3 out of 5 points. Maybe you want to take one for the team and just not even worry and not even put forth any more of your resources and just be good with that. I lost 2 points. Big deal. I'm okay with that. Or do you want to fight for those other 2 points? I've got to tell you, it's going to take you 10 minutes. You're going to go for it for the 10 minutes time or 5 minutes time? So if you're going to fight for it, then you're going to probably need to take this and you're going to say, okay, so 4a plus 2b plus 5 equals 3. Now you're probably asking yourself, where'd you get 4 from? Well, it's ax squared, and my x is 2, and 2 squared is 4, so that's where I got 4a from. Where'd you get 2b from? Well, it's plus b times x, and the x is the 2. So I got 4a plus 2b plus 5. Where'd I get the 5 from? Well, I know c is 5, and all that equals 3. So if I clean that equation up, I get 4a plus 2b equals negative 2. So I'm going to hang on to that equation for a minute. And if I look now at this last set of points, when I square that 1, that's going to give me negative 1, it's going to give me 1. So I'll have a plus b. So a minus b plus c plus 5 equals y, which in this case is 0. So if I clean up that equation, I'm going to have a minus b. I said I'll have a minus b equals negative 5. So now it's as if I got a system of equations with those 2 equations, and that's really not that bad. It's really not that bad, especially if I take that second equation there, the orange one, and I multiply that by maybe 2. You picking up what I'm putting down here? Okay, so I'm just going to essentially recopy this first one, 4a plus 2b is negative 2. I'll just copy that. The second one, I'm going to distribute a 2 through everything, so I'm going to have 2a minus 2b, and that's going to equal negative 10. And if I add those 2, I'm going to get 6a is negative 12. So then I know my a value is negative 2. So back to my answer then. Back to my answer, I know that my a value is negative 2. Backfilling, I'll go back to the orange equation. A, negative 2, minus b is negative 5. So I guess b would be 3. And that's it. And that's it. So that's going to be plus 3x plus 5. Okay. So y equals negative 2x squared plus 3x plus 5 would be my final answer. What do you think about that? I'll tell you this, both of the questions are going to give you the c value on both of them. They're going to give you the c value on both of them. Do we want to try one more, or are we okay with that? I'm going to assume that we're okay with that. You can go back, check those, practice those on your own. While we're kind of at somewhat of a stopping point, I want to direct your attention to this website. It's pretty cool. It's one that I actually use to generate practice problems. It's called CUTA, K-U-T-A, CUTA software. So if you type in the URL, K-U-T-A, CUTA software, you can go to their homepage, and there's free worksheets. It's pretty neat, free worksheets. And if you want to go to Algebra 2, anything that we're studying just about is going to be on here. So if you want to know more about matrices, you can look at that. We're looking at quadratic functions. So if you wanted to look at factoring quadratic expressions, you could do that. You could bring up that document. And the cool thing is, each one of these documents it's a PDF, and the last couple of pages have the answers on it. So if you feel like I'm not giving you enough homework exercises, please, by all means, go to this website. There's all kind of practice problems out there for you. Okay. All right. So, intro to factoring. Here we go. The factors of a number. The factors of a number are, this is a definition, so this is the definition of the factors of a number. The factors of a number are integer pairs whose product is the number. It's kind of a weird definition. The factors of a number are integer pairs whose product is the number. I've been educating minds, old and young alike, in algebra concepts for 16 years now. And I got to be honest with you, factoring is a very pivotal point in respect to mathematics. There's basic number sense. There's addition of integers, subtraction of integers, and then there's fractions, rational numbers, irrational numbers. But when it comes to factoring, there's something about factoring that makes it a pivotal point. If you can factor, you can do any more advanced math that comes beyond factoring. If you struggle with factoring, you're going to struggle with any advanced math that comes beyond factoring. Factoring is kind of like the ultimate goal in Algebra 1. And in Algebra 2, the factoring that we do is a little bit more advanced than the factoring that was done in Algebra 1. So it's imperative that you're able to look at the number like 144 and come up with all its factors. So for instance, example, find all factors of the number 144. Now, of course, most people know that 144 has a factor of 144 because every number has a factor that's the number itself and 1, right? So I like to list these things out in terms of pairs. I like to, and you don't need to make a tree or anything, but I like to list them out in this format where they're side by side, and I can look at them because when we go to factor, we're going to need to be able to find their sum and their difference to find out what goes in each part of the kind of factoring we're going to be doing. Now, one thing that I don't know if your 6th grade teacher taught you, divisibility rules. Anybody remember any of them? If you want to be able to factor, you're probably going to need to know your divisibility rules. Divisibility rules. It basically says a number is divisible by this if that. A number is divisible by 2 if it is what? Anybody remember this one? If it's what? Somebody said it. If it's even. A number is divisible by 3. For example, the number 51. Everybody thinks 51 is prime. It's not. Check it. 51 is 5 plus 1, which is 6. And 6 is divisible by 3 evenly. So 3 is divisible by 3. The number 10,101 is divisible by 3. Why? Because 1 plus 1 plus 1 is 3, which is divisible by 3. A number is divisible by 3 if the sum of its digits is divisible by 3. A number is divisible by 3 if the sum of that number's digits is divisible by 3. That's probably one that you didn't know, I bet. Maybe some of you did. Anybody know that one? Okay. A number is divisible by 4. There's a couple different ones you could use for this, but by 4 if the last two digits are divisible by 4. So what that's telling you is if you had something like 324 is going to be divisible by 4 because 24 is divisible by 4. Another way to think about 4 is if 2 divides it evenly. And I like to use that one. Cut something in half. If that quotient is still even, then it's going to be divisible by 4. A number is divisible by 5. Everybody should remember this one. 5 if it ends in what or what? 0 or 5. Nice, good. Number is divisible by 5 if it ends in 0 or 5. Now, you might think this is kind of elementary to go through all this, but if you're factoring a number and there's going to be a quiz that I'm going to give you, and you're not allowed to use a calculator on it, and you're going to have to find every single pair of factors of a number, and it's going to come down to you being able to go all the way to the middle group of factors of a number to find it. You're going to be like, this doesn't factor, and I'm going to be like, well, yes, it does. You're going to have the perseverance to be able to find all the factors of a number to do some of the exercises or some of the questions I'm going to assign you. A number is divisible by 6 if it is divisible by both 2 and 3. A number is divisible by 6 if 2 divides it and if 3 divides it. Now, there used to be a rule for 7. I honestly don't know it, and I think it's pretty complicated. So 7's one of those ones you're just going to have to check. A number is divisible by 8 if 4 divides it evenly. If 4 divides it evenly. There's only 2 more of these. A number is divisible by a 9 if the sum of its digits is divisible by 9. So if you add up all the digits and their sum is 18 or 27 or 45 or 9 for that matter, then the number itself is divisible by 9. And the last one, a number is divisible by 10 if it ends in 0. Now, of course, you could extend some of these ideas a little bit further. A number is divisible by 12 if it's divisible by 6 evenly. A number is divisible by 14 if it's divisible by 7 evenly. Okay, so let's look at 144. I purposely picked 144 because it has a boatload of factors. We know it's even, so 2 is going to divide it. 2 and what's half of 144? 72. Nice, good. What I like to do sometimes is I like to play leapfrog. I know since 2 divided it evenly that 4 is going to divide it half as many times as 2 did. So it's going to be 4 and 36. And since 4 divided it evenly, I'm going to leapfrog. I don't know how much room I'm going to need, but I know that 8's going to divide it half as many times as 4 did. So it's going to be 8 and 18. Okay? And since 8 divided it evenly, I know that 16 is going to divide it half as many times as 8 did. So it's going to be what, 9 and 16? Okay, so 9 and 16. We actually didn't have to leapfrog too far down on that one. Okay. Oh, well, I missed a couple. What about 3? Is 144 divisible by 3? 1 plus 4 is 9, which is divisible by 3. So 3 into 144, that's 3 times 4. Is it 48? 3 and 48? Okay, so 3 and 48. If you're not sure and you can't divide old school division, you're going to have to do that in Chapter 5 with polynomials. So if you don't know the algorithm for old school division, make sure you can divide the old-fashioned way. Yeah, it is 48. Okay. 144 is not divisible by 5. It is divisible by both 2 and 3, though. So because it was divisible by 3, 48 times, it's going to be divisible by 6 half as many times as 3 divided it. So it's going to be 6 and 24. 7. 7's one of those ones you're just going to have to check. Does 7 go into 144? Not evenly. 7 goes into 14 twice. So that's going to be, what, 20 and a 7. So that's not going to work. So 7 doesn't work. 8 worked. 9 worked. 10, does 10 work? No. What about 11? Probably not. What about 12? Yeah, 12. 12's going to work because 6 did. 12's going to work half as many times as 6 did. So 12 and 12. And I think that's it, huh? Okay. So how do we feel about being able to find the factors of a number, okay? The better you can do that, the easier factoring is going to be. You know what's weird? To divide, you have to be able to divide, multiply, subtract, and bring down, and do that all over again. So to divide, you have to be able to do everything. To factor, you're going to have to be able to factor. I know that sounds redundant, but to factor, you're going to have to be able to factor. That's just how it goes. So the easiest type of factoring that we're going to see is going to be to factor something like this. X squared minus 18x minus 144. So what factoring means most of the time, what they really want is us to rewrite. What we're really doing is rewriting the trinomial as a binomial times a binomial, as a binomial times a binomial. That's really what we're doing. And the reason that I took half of a week out of a class to go over this foiling thing is you could guess and check by foiling. So we know we're going to have something like this. And whatever we multiply this out by, this times this, it should equal what we start with. And I think we kind of get that idea. So what I like to think to myself is, what can I multiply by here and here to get that thing? And I think that's pretty easy to come up with. What's that going to be? X and X. Now, some of you, I'm sure, have been taught this box method. I'm not saying anything bad about the box method. Matter of fact, when we get into factoring some other things, I'm going to show you a couple techniques that I've learned that are a little different than the box method. Maybe you'll like them, maybe you won't. But this is how I factor. This is the way I've always approached it. When I go to find this number here and this number here, what I'm doing is I'm looking at this number. I said to be able to factor, you have to factor. So I need to know 144's factors. And when I find them, I know 1 and 144 are the factors, but I'm trying to find the ones whose sum or difference, either positive or negative, is going to match that number in the middle. And I know that 1 and 144, they add up to 145, or they subtract to be 143, and neither of them is the same as 18, so that pair's not going to work. So I got to go further down the list. Maybe it's going to be 2 and 72. That'd give me a 74 or a 70. Nope, it's not going to be that. Maybe it's going to be 3 and 48. Well, that'd be 51 or 45. It's not going to be that. Okay, maybe it's going to be 4 and 36. That'd be 40. That'd be 32. That's not 18. Oh, man. Maybe it's going to be 6 and 24. 24 plus 6 is 30. 24 minus 6 is 18. Oh. So I guess it's going to be 6 and 24. 6 and 24. Now I got to figure out my signs. Now you got to think back to your 7th grade days. A negative times a positive is a negative. So one of them's got to be negative. And I'm trying to make a minus 18 out of the 6 and the 24. So where's my negative sign go? on the 24. So a minus on the 24 and a plus on the 6, like that. That'll get it done. Okay. Cool beans. So that's kind of the idea behind factoring trinomials. What do you think? You remember doing that? On a 1 to 10 scale, 10 being, oh my gosh, I can't do this. 1 being, I could do this with my eyes closed. How do you feel right now about being able to factor those? Okay. I'm getting a range of responses from like 1 or 2 to 6 or 7 or 8. Okay, let's try another one. Let's try another one. Example 2, factor, x squared plus 5x plus 6. So anytime that everything's positive, these are nice. These should be easy money. Matter of fact, I like to call these easy money, like that. Because if everything's positive, right? Nothing else it can be. So we got to ask ourselves, what's 6's factors that add up to 5? 6's factors, 1 and 6. 1 and 6 makes either 7 or 5, so it could be 1 and 6. 2 and 3 is going to make 5 or 1. So which one is it, the 1 and 6 or the 2 and the 3? It's got to be 2 and 3 in this case, right? Okay. So far, so good? I want to run the whole gamut with all the signs of this one, because this might show up on one of your quizzes. Example 3, factor x squared minus 5x plus 6. So anytime that last term is positive, what do you know about the signs of the binomials? If that's positive and this is negative, they got to be minus minus. If this is positive, they have to be the same. So yeah, they're both going to have to be negatives here. So again, we'll go with an x and an x, and what's going to get it done here? Going to be a 2 and a 3, and again, right? 2 and a 3 again. Okay, let's try example 4. Factor x squared minus 5x minus 6. Ooh. So when that last sign's negative, we know one's got to be positive, one's got to be negative. Because of the commutative property of multiplication, it really doesn't matter. If you want to put your minus first, plus second, it doesn't matter. It's totally up to you. Totally up to you. But we're going to have to go with an x and an x. Think the 2 and the 3 will get it done here? Well, going to have to go with the 1 and the 5 then, right? Or 1 and the 6, I mean. So which one gets the negative? 6. Which one gets the positive? The 1, and then that's it, right? Example 5, factor x squared plus 5x minus 6. So what's that one going to look like? X and an x and plus 6 and minus 1, right? So those ones you should be doing backflips when you get to ones that easy. What makes those so easy? If we think back to this ax squared plus bx plus c form, if a is 1, if a equals 1, factoring is easy. I dare write 2 letters afterwards. I better not. I'd probably get in trouble. You could probably guess which 2 letters I would write afterwards. One of them's a vowel, one of them's a consonant. The first and 6th letters of the alphabet, respectively. Okay, you get the idea. If A is not 1, good luck. These shouldn't be that hard, but for some reason they are. For some reason they are. Does anybody know Jane Rader? Jane Rader, I think she graduated a couple years ago or last year. The technique that I show to factor those, Jane Rader adopted that, and she really liked it. Mr. Englehart uses a different idea. There's no right way or wrong way to factor. You get the right answer or the wrong answer, but there's no technique that's better than any others. But some of you are going to like some techniques better than others. So there's this idea, there's this concept in mathematics. It's called FBG. Now, don't get it twisted. There's a lot of acronyms we're going to see in this section. Don't confuse that with FRBR. You'll find one of those at the county fair. One of those stickers that says for rednecks by rednecks. FBG is a technique of factoring. It's called factoring by grouping. Factoring by grouping. In the general case, if it goes like this, RA plus RB plus SA plus SB. So that's the general form of it. And it's pretty neat, it's pretty fascinating, it's pretty awesome the way it works. What makes these work is that you have 4 terms to start with. You have 4 terms to start with. And the trick is you're going to pair 2 and 2. You're going to pair the first 2 and the second 2. You're going to pair together the first 2 and the second 2. And what you're going to do is you're going to factor out. You're going to try and factor out the GCF. Now, we haven't talked about the GCF yet, but you probably know it's the greatest common factor. It's what's the same to both of these. So if I just look at RA plus RB, they have something in common. What do they have in common? An R. Good. So if we factor out the greatest common factor, what we would say then is this can be rewritten as R times the quantity of something. Well, if you divide both of those by R, it's going to leave an A, and it's going to leave a B, and there's that plus sign in the middle, right? Everybody with me so far, I hope? So we're going to factor out the GCF out of the second pairing also. So if we go over here and look at the second pairing, what's the GCF there? It's S. So again, we rewrite this as S times the group A plus B. Now, one thing you might notice that happens, and if factoring by grouping is a possibility, this is going to happen every time. This thing here and this thing here, my highlighters are slow, those things end up being identical, don't they? And there's one more thing that I forgot to write out here. There's a plus sign here. Okay. So what ends up happening is we end up with the quantity of A plus B. And here's where people get this twisted. They don't understand it. It looks to me like we need to distribute an R back into it, and we need to distribute an S back into it. And if we FOILed this back out, we would end up with right back where we started. So that's kind of the algorithm, the model, the procedure, the steps that these things take. And this is a very effective technique to factor, in my opinion. So I'm going to look at an example when A is not 1, and we'll factor it, and it's going to be awesome. You ready? Do, 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 do. Boy, they need some better ones than they got in this book. I guess the 5, 12, and 32 will get it done. Example, factor 5x squared plus 12x. 5x squared plus 12x minus 32. And I know what you're probably thinking. You're thinking, well, Mr. Minnick, you just spent all this time. You just showed us factoring by grouping. You said it works if there's 4 terms and that only has 3 terms. So I don't understand. How could I possibly use factoring by grouping because this only has 3 terms? Well, to be able to factor by grouping, sometimes you got to manipulate something. In algebra, there's going to be some things that you have to figure out that you're going to have to come up with some magic trick out of nowhere. And this is one of those times. If you use factoring by grouping on this, the magic trick is rewriting 12x in some way so that we end up with 4 terms. And the way this factoring by grouping on this works is I'm going to have to take 5 times 32. That's going to be 160. And I want 160's factors that are going to equal 12 if I add or subtract them. Oh man, 2 and 80, 4 and 40. 3 doesn't go into it. 4 went into it 40 times. 5 goes into 160 36 times. 6 doesn't go into it. 7 I don't think goes into it. 8's going to go into it 20 times. Oh, 8 and 20. 8 and 20. So what I'm going to do is I'm going to rewrite that plus 12x using 8x and 20x. Now, if I wanted those to add up to 12, that's going to have to be plus 8x and minus 20x, right? Like that? Okay. Did I get, oh, I got the signs twisted? Sorry. My bad. So that's going to be minus 8x plus 20x. Okay. So this 5x squared that's out front, I'm just going to rewrite that. I said I'm going to rewrite it. This 5x squared that's out front. And then this minus 32, I'm just going to rewrite that. Minus 32. And now I can factor by grouping. Can't I? What factors out of the first two? An x. Okay, so that's going to be x times 5x minus 8. What factors out of the next two? A positive 4, which leaves behind 5x minus 8. Ah! This is cool. So my answer then would be the quantity of what times the quantity of what? 5x minus 8 and x plus 4. And that's it. And that's it. We'll do some more of those on tomorrow. I wanted to see that for the first time. Anybody ever see it factoring done that way when A is not 1? It's pretty cool. It's a lot of work on the front end of things, but it works all the time. Sometimes you're finding factors of some pretty big numbers. The last thing I want to show you today, we're kind of running short on time. GCFs, factoring out a GCF. Suppose we had something like 3x squared y cubed minus 15x cubed y squared plus 36xy. If you need to find a GCF, it's the greatest factor that's common to all of those. There's no right or wrong way to do this, but sometimes breaking things down into their prime factors, 3x, x, y, 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 minus 3 times 5, x, 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 y, y, plus 36 is, what's that, 2 squared times 3 squared, x, y. So I'm looking at how much stuff is common to each of those. It looks like they each have a 3 in them, right? They each have a 3 in them. So I'm going to underline the 3. Now the one has a 5 in it, but the other ones don't. The one has a 2 in it, but the other ones don't. It looks like each one of them has at least one x in it, right? So I can only underline that one x because that's the most that's common to all of them. And then with the y's, it's just one y that's common to all of them, right? So my GCF in this case is 3xy, and when I factor that out, this is why I like using this method sometimes. What's left would be xy squared minus 5xy. Is that right? 5x squared y, thank you, on the 5, yep. And then plus, what would that be, 4 times 3? I guess that's plus 12. Plus 12, right? So we'll do some more with GCFs tomorrow. We'll do some more with factoring tomorrow, but this is an introduction to factoring. I hope it's been educational. I hope everybody has a fantastic Monday. See y'all next time. Good.